Hey everybody, this is Mr. Ainsworth, and we're going to get into a big review here on exponents and exponential functions. We're talking rational exponents, positive exponents, negative exponents, where the base is an integer and also a fraction, as you can tell through here. So get ready to go. Have your TI-84 graphing calculator nearby. If you have one, take that out, get that ready, or your scientific, whatever you have. We'll use it when appropriate. Okay, here we go. We're going to start off doing some arithmetic here and evaluating some expressions, arithmetic expressions here. So we got to be good at this because these basic skills are needed when you graph exponential functions. All right, so here we go. 1/2 to the negative 4 power plus 1. So what we're going to do is we're going to interpret this negative exponent as a reciprocator, okay? And I taught you guys to reciprocate your base first and then take it to the power of 4, okay? Because this is actually 1/2 to the negative 1 power raised to the 4th power using our power to power rule. So we always reciprocate first. I'm going to write that down. Reciprocate first, okay? Now the reciprocal of 1/2 is 2, and then we got to take it to the 4th power and then add 1, which means you got to be good at your powers of 2, 3, 4, 5, and 6, which you guys are. I know my students are because we practice this on a daily basis. Okay, for example, we did this powers of 2. We said 2, 4. We keep on multiplying by 2. That's what powers of 2 are. So 2, 4, 8, 16, 32, 64, 128. See, that's 2 to the first, 2 squared, 2 cubed, 2 to the fourth, 2 to the fifth, 2 to the sixth, 2 to the seventh, 256, that's 2 to the 8th, 512, to the ninth, 1024. That's 2 to the 10th power. All right, so you got to be really good at your powers of 2. Now, 2 to the 4th happens to be 16, okay? Use your fingers, okay? Can't do that on this video, but we do this in class. So keep track on your fingers and you can do powers of 2 real easily. So this is actually 16 plus 1 or 17. All right, on this next one, we reciprocate first. So 2 times 3 to the second power. So 3 to the second power minus 5. All right, what's that? Well, that's 2 times 9 minus 5. 2 times 9 is 18, and 18 minus 5 is 13. All right, so we step it out. We reciprocate first from here to here. Then we evaluate your exponents and follow the order of operations. Then we multiply before we subtract. So 2 times 9 is 18. And then we subtract 5 to get 13. Okay. Now, in this 5 to the negative 3 power, there's a couple ways to interpret it. It's either you can reciprocate 5 to get a fifth and then take it to the third power. That's one way. Or you can write it like this: 5 times, right? 1 divided by 5 cubed. That's the same thing as 1/5 raised to the third power, which means you got to be good at your powers of 5. Okay, so let me do that over here where we got some room. So powers of 5, and we've done this too in class. 5, and you keep multiplying by 5 here. So 25, 125, 625. So this is 5 to the first, 5 squared, 5 cubed, 5 to the fourth. You got to be good at your powers. When you're good at your powers, you can do all of the roots. You can and you can evaluate any base to any power. Okay, if you're good with your powers. Okay, so 5 times 1 divided by 5 cubed minus 5. So this is 5 cubed, as I said over here, 125. So this is equal to 5 times 1 divided by 125 minus 5. Okay, then we simplify. 5 into 5 is 1. 5 into 125 is got to be 25, right? We know that because 5 times 25 is 125. So once you know your powers, you can also divide and go backwards like I did here and simplify your fractions. Okay, so what do we get? We get 1/25 minus 5. Well, that's negative 4. And if you take out 1 from 25, then 24 out of 25 remain. Okay, on this next one, we get 4 times 1/4 squared. You got to square the numerator and denominator, or you can multiply 1/4 times 1/4. Either way, you get 4 times 1 divided by 4 squared, or 1/16 minus 4. Do a little simplifying, divide them both by 4, and what you get is 1/4 minus 4. which is -3 and 3/4. Why? Because if you take out 1 from 4, then 3 out of 4 remain. And not like that, small minus big is always negative. Okay? We practice this arithmetic a lot in class. You just got to get good at it. Okay, this next one is 9 times 1 divided by 3 cubed plus 2. So it's 9 times 1/27th plus 2. And you simplify. Divide both by 9, you get 1/3 right there. And 2 plus 1/3 is, whoa, that's 2 1/3. Okay, on this next one, we got 1 divided by 6 cubed minus 9. Now, we already talked about this. 6, oh, power, no, we didn't talk about it. So now we got to do powers of 6. So powers, okay, whoa, what's that? What happened here? Okay, didn't mean to do that. Powers of 6. Here we go. So 6 times 6 is 36, times 6 is 216. There we go. So we have 6 to the first, 6 squared, 6 cubed. So this is 3 times 1 divided by 216 minus 9. Divide these guys by 3. All right. 3 into 21 is 7. 3 into 6 is 2, so it's 72. So what we get is 1/72 minus 9. So 1/72 minus 9, that is -8 and 71/72. Okay, it's not that bad because we practice this so much in class. So if you go back and look at all our previous work, we did this all day long. Okay, you got to be good at the arithmetic. Okay, we know that y to the 0 power is 1 by definition. We talked about that. So this is 1 right here. X to the -7 is 1 over x to the 7th times w to the 8th. And so you have w to the 8th divided by x to the 7th. Why? Because when you multiply fractions, you multiply the numerators, and then you multiply the denominators. Okay? 1 times w to the 8th is w to the 8th. All right, next one. This is the square or the power. Okay, the square or the power, and this right here is the cube root. And I talked to my students here, and I said, hey guys, always root the number first. Take the cube root of 64 first. That reduces the size of the number, and then square it. Okay, not too many people know what 64 squared is. I mean, that's a big number. 64 times 64. I mean, that's close to 4,000. So forget that. It's cube rooted first. We know that too, by the way. And we haven't done powers of 4 yet. So let's do powers of 4. Powers of 4. Well, what do they look like? Well, 4, 16, all right, 64, 256, and so on. This is 4 to the first, 4 squared, 4 cubed, 4 to the fourth. Okay. And since we know 4 cubed is 64, the cube root of 64 is 4. Because if you know your powers, you know your roots. So we take the cube root of 64 first and then raise it to the second power. That's 4 squared, so we go from here to here basically. All right, and we get 16. So you cube root it first and then you square it. Here you take the 4th root of 16. Now the 4th root of 16 looks like this in radical form, and then you cube it. Okay, now what is the 4th root of 16? Well, we talked about that earlier in the powers of 2. It's right here. If 16 is 2 to the 4th, then the 4th root of 16 is 2. Why? Because 2 to the 4th power gives you 16. So this is actually 2 cubed, and that's 2 times 2 times 2, or 8. Here, this is the square root of 16 cubed. So you got to take the square root of 16 and then cube it. And that's 4 cubed. Let me see, what is that? Well, we did powers of 4, right? And that's 64, right? 4 times 4 times 4 is 64. So this is 64. So it pays off knowing your powers, guys, and that's why we drilled it so much in the beginning. All right, and then powers of 3. Have we done that? No, sir. So let's do that too. So powers of 3. 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. So this is 3 to the first, 3 squared, 3 cubed, 3 to the 4th, and then 3 to the 5th. All right, so if the 4th root of 81, the 4th root of 81 has to be 3. Why? Because, look, 3 to the 4th equals 81. That's what it's all about. Okay. What is the 7th root of 128? Well, let's find out. So let's look at powers of 2. You got 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the 7th. Oh, 2 to the 7th. Use your fingers. Okay. So the 7th root of 128 has got to be 2. Why? Because 2 to the 7th equals 128. That's the reason why. Just like here, 3 to the 4th equals 81. Okay, this is the reason why right here. You have to know that. Okay, and then of course look back up here. 2 to the 10th is 1024. So the 10th root of 1024 has got to be 2. Why? Because 2 to the 10th power gives you that number. Okay, so these are the reason whys. The answers are 3, 2, and 2 here. However, the reason why is in red. Okay, and the cube root of 216 is got to be 6. Why? Because 6 cubed is 216. And the 4th root of 625, what's that? Look at the powers of 5. Okay, the 4th root of 625 has got to be 5 because 5 to the 4th, it gives you 625. Okay, so this has got to be 5. Why? 5 to the 4th is 625. On this one, this becomes 2. Cube root of 8 is 2. 2 to the 5th is 32. Okay, you have to know your powers. Okay, so do that. All right, so practice and develop your skill. Okay, so let's get some more here. Let's do some more. All right, so the cube root of 27, well, that is 3. 3 squared is 9. That was an easy one. Cube root of 64, well, that's got to be 4. All right, 4 cubed, well, that's back to 64 again. All right, cube root of 10,000 or 1,000 has got to be 10. So that's 10. 10 squared is 100. All right, the reason why this is 10 is because if you take 10 and cube it, you get 1,000. All right, and the cube root of 234, whoa, this should be 243. Fix that, guys. All right, fix. So the cube root of 243, well, I meant that's got to be, ooh, I didn't mean cube root. I meant 5th root. Oh, actually, you know what? Don't have to fix this. I did that on purpose. Okay, we don't even know what this is, but who cares? Anything to the 0 power is 1, right? All right, look at this. Okay, I made it, overthought it. You know, sometimes we do that. Okay, any non-zero number to the 0 power is 1. So even though you don't know that, I mean, even though you don't know what this is, so I'll put a question mark there. Who cares? It's to the 0 power. It's 1. Easy. Okay, on this one here, all right, we multiply our constants. 9 times 4 is 36. And then we add exponents here when we multiply like variables. So we have x to the negative 2, and that's equal to 36 divided by x squared. Always write your answer using positive exponents. Okay, this right here, the cube root of 27 is 3 times x times cube root of 125 is 5 times x to the 5th times the square root of 4 is 2. So you first simplify and then you multiply your constants, right? So let's figure that out. 3 times 5 is 15 times 2 is 30. So you have 30 times x to the 6th. All right, you have to add your exponents here, all right, just like you did on the previous one. Negative 7 plus 5 is negative 2. All right, so you got to know your basics, and you have to go back to the beginning, guys, and review. All right, the cube root of 8 is 2, and 2 to the 5th is 32. So this right here is 32 times x to the, let me see, x to the negative 8 times x to the 7th. Let's do that right now. This times this right here is just x to the negative 1. All right, so I multiply my like variables first, see? And then I work with my constants. The cube root of 27 is 3, and 3 squared is 9. And the square root of 9 is 3, and 3 cubed is 27. Okay, so now I have to multiply my results. Okay, so let's do that. 32 times 9 times 27. You get 7,776. So this is 7,776 times, right, times x to the negative 1. But you got to rewrite that. So that's 776 divided by x. Okay? Remember that negative 1 shifts the exponent down below. Okay? Right there. All right, so my answer looks like this right here. All right, kids, keep pressing on. Here we go. Multiplying like bases here. So this is equal to 2 to the negative 3 plus 5, which is 2 squared divided by 2. And that's 4 divided by 2, all right, which is 2. And this is the cube root of 8, which is 2. And this is equal to the square root of 4, which is 2. So which expression equals 2? Let's read the directions. Which expression equals 2? Well, this one, and this one, right? Because they all equal 2. Look at that. Boom, boom, boom. All of them. So let's write that down. All of them. Okay, right? Each in radical form. So let's do that. So this is the cube root. So let's write the cube root first and then square it. This is a square root. So the square root of 7 to the 5th. And this is just the square root of 4. I don't have to evaluate it. I want to write it in radical form only. No need to evaluate. Because it doesn't ask. Okay, it just says write in radical form. Okay, so those were the basics with the arithmetic and the rational exponents. Now let's get right into an application problem dealing with a growth situation. Okay, so let's read the problem here. Okay, so Shannon bought a $150 porcelain doll. That's pretty expensive. Which increases in value 30% per year. Okay, show its future value per year for each year for the next 7 years. Okay, so let's analyze this. Okay, first of all, the porcelain doll costs as initial cost. So this is A sub I, right here. That's your initial cost. Initial, okay, or starting cost. Okay, starting value. And then right here, it increases. This is the key word here. Increases, grows. So this is a growth function. So 30% per year. So there's your time period right here, every year. So that's R. So let's analyze that or detail that out. R is 30%. 30% is a decimal. Let me see. 30% means 30 per 100. So 30 divided by 100. Well, that's 0.3, right? So, or you can say 0.30, either one. Per year. So there's your time period. All right, so what is the growth rate? So R is equal to 30%, and you always change it to a decimal, okay? Always change to decimal. Change to a decimal. All right, so let's put that in parentheses there. So I know my growth rate. That's what I want to find. That's R. I know this is a growth function, so we need to model that. Okay, so my growth function in general looks like A sub f is equal to A sub I times 1 plus r, not 1 minus r, okay, to the t power. So what is it for this one? Well, so that tells me that A sub f is equal to 150, all right, times 1 plus r, which is 0.3 raised to the t power. There's my growth function. Okay, that's the growth function. Now what I want to do is understand that t, all right, is the number of time periods, which is years in this case, because it says it grows 30% per year. So t is equal to the number of time periods or number of years. Okay, so let's figure out the future value. So we start off at time equals 0, or in the beginning with the present value of 150. All right, now it increases in value 30% per year. So after 1 year, because it's per year, per 1 year, there's your time period right there. A sub f is equal to 150 times 1 plus 0.3 raised to the first power. Okay, that's after 1 year. After 1 year. That's what this number means right here. All right, so let's get our calculators out and compute that. So 150 times 1.3. We don't have to raise it to the first power because it doesn't change the value. So after 1 year, we're up to 195. Ooh, okay, we made some money. So 195 bucks. All right, so we paid 150 of it, but in 1 year, or it raises or increases its value, okay, it grows, it gets more valuable over time by 30% per year. Okay, the next year, so what's the future value after 2 years? So a sub f equals 1. You can put 1.3. That's a little quicker way to do it. All right. And after 2 years, well, there's 2 time periods, right? Because the time period is per year. All right. So let's calculate that. So 150 times 1.3 raised to the second power. All right. And you get $253.50. So 253.50 cents. Another way you can get that is simply take this and you multiply it by 1.3, and I'll show you. Check this out. We had 150 or 195 to start, right? So if you multiply it by 1.3, watch what happens. Oh my goodness, we get the same value. You just keep multiplying it by 130% because it grows 30% every year. All right, but I'm going to use the function because that's the way I taught you guys. So you take the initial value times 1.3, raise it to the third power. Why? Because this is after 3 years. Okay, so the future value should be 150 times 1.3 to the fourth power. So what's that? Oh, I didn't calculate the third power. I'm getting ahead of myself here. So let's calculate that. So 150 times 1.3 raised to the third power. We'll do that first. Okay, you get $320.55. So $329.55. And then you got to multiply it by another 135% or 130%. So it's 150, all right, times 1.3 raised to the fourth power. All right, $428.42. So $428.42. So notice how the value is increasing. You keep multiplying by this growth rate because it gets 30% larger every single time. So let's continue. So after 5 years, it's $150 times 1.3 to the fifth power. Again, you just take the number of time periods, which in this case is the number of years, because if you read the problem, that's what it says. It says 150 times 1.3 raised it to the fifth power now. All right, and you get $556.94. Let me read that again. Let's see if I wrote it down right here. 556. Yes, I did. Okay. And so you can calculate that simply by multiplying it by 1.3 again. You can check these values. After 1 more year that passes, the value of the doll increases by another 30%. So by using the function, you could take it to the sixth power now. So 150 times 1.3 raised to the sixth power. All right, and you get a larger value, right? Because it's increasing over time. So $724. All right, and 2 cents. You get that by multiplying by 1.3. You can check my numbers. All you really have to do is keep on multiplying by 1.3 because these are consecutive years. Okay, if this didn't work or if it wasn't consecutive years, well, then you'd have to calculate it using your function every time. That's why I'm doing it this way anyway, so I'm showing you how to use the function. All right, you always use the growth function, 1 plus your growth rate. All right, times your initial value raised to the number of time periods, which in this case is 7 because it's after 7 years. Okay, so what is that? Well, let's say 150 times 1.3 raised to the 7th power because it's 7 years have gone by. And so that's $941.23. So $941.23. Okay. Okay, so that's how you use your growth function here. And I'm talking about this bad boy right here. This is the most important one right here, your growth function. All right, you always take 1 plus your growth rate times your initial value raised to the, the base is being raised to the number of time periods. T is the number of time periods, which in this case, if you read the problem again, is per year, right? So after 1 year goes by, that's 1 time period. After 2 years, 2 time periods, and so on. Okay. Now, in this section here, we're going to do a little review. Okay, because we're going to do something with these linear functions that we studied last semester, and we're going to do something together with the exponential. So let's review here first. So review the linear function, and these are in slope-intercept form. Okay, y equals mx plus b. Well, at least the first two are, and then these two are in your standard form here. So we're going to have to solve for y. That's what it says right here. Okay, so let's take a look at the slope. The slope here is 1/3, and the y-intercept right here, this is your b value. B is 2, or you can say 0, 2. So you want to plot that first, 0, 2 right here. On the y-axis is the y-intercept. Slope, this is the slope. All right, rise over run, rise divided by run. And so from here, you're going to go up 1, right 3. 1, 2, 3, plot a point. And let's reverse it. Down 1, left 3. 1, 2, 3. Okay, and let's plot. And let's graph the line here. Right there. Okay, next one. Slope's negative 2/3. Notice how I just brought the negative up top. Y-intercept's -1, or 0, -1. So this is down 2, right 3, from -1. So you plot -1 first, right here. And then you're going to go down 2, 1, 2, and then right 3. 1, 2, 3, and then reverse it. So you go up 2, 1, 2, and then left 3. 1, 2, 3. You reverse both directions. And notice it's linear there. It's straight. Okay, and then you graph your line from there. All right. Next one. We have to solve for y. So let's subtract x on both sides. And you get y is equal to -x plus 3. So the slope's -1 and the y-intercept's 3. So let's start up here at 3. And for a -1 slope, it's -1 over 1. So it's down 1, right 1. So down 1, right 1. 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 And so when you graph your line, after plotting a whole bunch of points, it looks like this. Okay, next one, you got to subtract 2x to get the slope-intercept form. All right, and then you get -5y is equal to -2x plus 10. Divide everything through by -5. Okay, and then what do you get? Let me see, you get y is equal to 2/5 x. All right, plus, or no, actually minus. Let's see, let's write it as minus here, because 10 divided by -5 is -2, so we're going to write it as a -2. So there's your slope, and there's your y-intercept. So we're going to start down here at -2, and then we're going to go up to right 5, because that's the slope. 1, 2 up, 1, 2, 3, 4, 5. There we go, and we draw our line from there. Okay, there we go. That's all there is to it. Okay. That's a quick little review of linear functions, okay, what you're going to need to know later on, because there's going to be a cool application problem on your test that you need to be able to solve. Okay, so you're going to have to incorporate your skills from last semester and this semester all together. Okay, now here's your growth and decay problems again. So this is a cool one. This is from biology or a science class. Okay, you got a dish, a petri dish. It has 480 bacteria in it. This is your initial amount. That's A sub I. That's your initial amount. So initial amount, A sub I. Population will grow. So this is a growth function. So already I know I'm going to be using A sub I times 1 plus r raised to the t power because it's a growth function. And here's your time period right here, and it gives you the value of r. So we got r is 70%, all right, which is 0.70, or you can say 0.7. Every 2 days, that is your time period. Okay, so let's answer the question here. How many bacteria will be present in 4 days? Okay, so the very first thing we always do is we calculate the number of time periods. How many 2-day periods do you have in 4 days? And so we do is we take 4 divided by 2 and you get 2. There's 2 2-day periods in 4 days. That should make sense. 2 2-day periods in 4 days. So now my function should look like 480, all right, times 1 plus the growth rate as a decimal, so that's 0.7 raised to the second power. So first I set up my time periods, okay, I figured that out. That's step number 1. Step 2, you set up the function, so you set it up. So this is time periods. There we go. So you set up the time periods, then you set up the function, and then you calculate on your calculator. So yeah, let's clear it out so it's more clear, and you get 480 times the quantity, 1 plus 0.7 or 1.7. Just type in 1.7, it's easier. And then you raise it to the second power, and then you compute. And you get about a 1387.2. So 1387.2, but you round it. Okay, so this is approximately equal to, all right, this is approximately equal to sign here, so let me write it better. So 1387 bacteria, because you chop off the decimal, right? All right, in 4 days. Now in 8 days, the question is how many 2-day time periods? Well, you take 8 divided by 2 and you get 4. There's 4 2-day periods. 4 times 2 is 8. Then your function, it looks similar, so it's 40 times 1.7 raised to the 4th power this time. So you take 480, multiply it by 1.7 raised to the 4th power. And you get about 4009 bacteria. So you got to round it. Okay, I've never seen a partial bacteria, so you got to round the numbers here. Okay, how many time periods in 11 days? Well, how many 2-day periods in 11 days? So 11 divided by 2 is 5.5 or 5.5. So my function now looks like 480 times 1.7 to the 5.5 power. And let's compute that too. So take 480 times 1.7 raised to the 5.5 or 5.5 power. And that's about 8,886 bacteria. So 8,886 bacteria in 11 days. Okay? All right. Moving along. Okay, next one. The house down the street has termites in the porch. Oh my goodness, that's not good. Okay, termites are bad little dudes. So you call the exterminator, and it's estimated that about he estimates there's 600,000 termites eating the porch. Oh my God, what are you gonna do? He said that the treatment he put on the wood would kill, okay, 40% of the termites every day. There's your time period. So right here, R is equal to 40%. So R is equal to 0.40. Okay, your time period is daily. Okay, that's your time period. So T here is 5 because over 5 days, there's 5 time periods because it's every day, not every 2 days, not every 3 days, but it's every day. So in 5 days, there's 5 time periods. So in this one, my future amount would be the initial amount, which is 600,000, times 1 plus 0.4, or 1.4 raised to the 5th power. So let's compute that. Let's clear out the calculator, enter in 600,000, multiply by 1.4 raised to the 5th power. That's not correct. Let me try it again. 600,000. Calculators are great, but if you don't press the right buttons, guess what? You're not going to get the right results. So you got to double check your work. You got to make sure you enter in 600,000 here. It has 5 zeros. So 1, 2, 3, 4, 5. Okay, and then 1.4 to the fifth. So that's 3,226,944. Let's put some zeros in here. I mean some commas in. So 3, 2, 2. All right, 6944. So 6944. Put the commas in. Ooh, that's 3,226,944. All right, termites. All right, next one. T is equal to what? Well, let me see. The time period is every day, right? 36 hours, there's 24 hours per day. So 24 hours equals 1 day. So you take 36 divided by 24. Let's do that. So 36 divided by 24. That's 1.5 days. Okay. So your future amount looks like 600,000 termites times 1.4 raised to the 1.5 power. So let's enter that in. Double check everything. All right, and so here we have 993,901 termites. All right. Okay, so how many after 3 weeks? Well, 3 times 7 that's 21 days. Okay, that's 21 days. So T is 21. So, because it's daily, right? Every day. So A sub F equals 600,000 times 1.4 to the 21st power. Okay, I just noticed something here. I did a very, very common mistake. Okay, we're not growing the termites, we're killing the termites. So guys, I apologize. Everything's right except I picked the growth function. This is not a growth function. This is the decay function. I can't believe I just did this. But you know what? It's okay. This is how you modify it. This is what you do. You don't erase your work. You modify your work. Okay? Because the only thing that changes is this little plus symbol right here. Okay? It's minus. Why? Because we're killing off. It's a decay. Okay, decay function. I don't know what happened here. So I want to use a sub f is equal to a sub I times 1 minus r to the t power because we're killing the termites. So it's a 40% reduction every day. So the number should get getting smaller, not bigger, and that's what I just figured out in my head. I'm going, what in the world's going on here? And you know, it's because it's over 10 o'clock, and you shouldn't do mathematics after 9 o'clock unless you have a test the next day or something, which we do. So, okay, so that's why I'm doing this here for you. So this is a good lesson of how to fix your work here. I noticed that this is a decay problem. It's 1 minus r, not 1 plus r. So let me fix my work. So I'm going to start over on the calculator. You don't have to change all your work. All this is correct. You just got to subtract 40%. So watch. So enter in 600,000 again times 1 minus 0.4, okay, or you can enter in 0.6. You know, 1 minus 0.4 is 0.6, because if 40% is gone, then 60% remains. So you can enter in 0.6 here if you want. All right, raise it to the 5th power. And you should end up with a smaller number here because we're killing these termites, not letting them grow. So I apologize. But you know, sometimes it's good seeing a mistake because guess what? I'm teaching you how to fix it too. So I'm showing you how to set up the problem correctly now and also how to fix the problem. So I'm not going to change this video and I'm not going to re-record. I'm just going to continue. Okay, so 46,656. I can't believe I did that, but a little embarrassing, but you know what? I've done this for years. I'm human. I make mistakes. Okay, so we got to subtract 0.4, guys. So let's re-enter this. Oh, by the way, this is a cool thing you can do. Watch this. You can go second entry, and it pulls up the function, and I go backwards a step, and I just change my exponent. That's what's cool about the T84. You can just change the exponent and then recalculate it. Okay, so look at my new answer here, 278,854. 278,854. Let me check that. 278,854.8. So I got to round it up one. So that should be a 5. Okay, termites. Okay, and the reason why there's less than 600,000 is because we're killing 40% off. And after 1.5 time periods, well, there's a lot less, right? So now the answers are making sense. Okay, so now this answer should be pretty small because when we go 21 time periods, there should be a lot less than 600,000. So let's check this out. So I'm going to go second entry here. I'm going to recall it, go back button here to my exponent, enter it in. Let's delete that exponent. And got to raise it back to the power. And then enter in 21 and then just press go. Well, look, there's only about 13 termites left. Okay, so the reason why is because over time, this is the number of time periods here, you want to eradicate them. You want to kill them off, right? So after 21 days, almost a month here, like 2/3 of a month, there's only 13 termites left. Why? Because we're killing them. Okay, we're not letting them grow. So this is the decay problem. Things are decreasing over time. Okay, they're decreasing over time. All right, now that I got that straight. So on this one, I won't make a mistake. Here we go. So on this one, we got an initial investment of $12,000 in a bank account. Given the current economy, your money's going to grow. It's a growth situation by 30% every 2 years. There's your time period. So A sub I is 12,000. Okay. The growth rate is 30%. That's 0.3. I'm going to be using this function here. A sub f is equal to A sub I times 1 plus r because we're growing the money to the t power. So here, how many 2-year periods in 8 years? So 8 divided by 2 is 4. There's 4 2-year periods, and that should make sense. 4 times 2 is 8. So A sub f is equal to your initial investment, $12,000, times 1 plus, because it's a growth situation, 0.3, to the 4th power. Okay, you want to take this number and raise it to the 4th. So let's figure that out. So 12,000, all right, times 1.3 raised to the 4th power. And our money should grow. And it does, $34,273. So $34,273.40, I think it said. Let me verify that. 20 cents. Okay. In 20 years, how many 2-year periods in 20 years? So 20 divided by 2 is 10. So 10 2-year periods. 10 times 2 is 20. So that makes sense. So A sub f equals 12,000 times 1.3, because it's raising 30% per year, to the 10th power. So just go ahead and go second entry, and then go back up to your exponent and change it to 10. All right, hit the enter button, so you don't have to enter the whole thing at once. I mean, the whole thing again. So 165,430 dollars and how many cents here? 19 cents. Okay, and that's money, so let's put a dollar sign on it. So in 20 years, we're going to start off with 12 grand, and we're going to end up with over $165,000. Hey, that's not bad, okay? Because it's a growth situation. It grows. That's why it's 1 plus r. Okay, in the previous problem, the one I messed up on, which I apologize, it's a decay situation, so it's 1 minus r. Okay? Okay. All right. Thank God we're getting somewhere here. So let's graph this exponential. So check this out. So let's start off with at a domain of from -3 to 3. So 4 times 1/2 to the -3 power minus 1. So we reciprocate first. So it's 4 times 3 to the 3rd, 2 to the 3rd. Man, it's getting late. So 2 to the 3rd minus 1. 2 to the 3rd is 8, so it's 4 times 8 minus 1. That's 32 minus 1, or 31. Okay. So notice the progression here. I reciprocate, then I evaluate the exponents. 2 cubed is 8. Then I multiply before I subtract. 32 minus 1 is 31. When x is 2, it's 4 times 1/2 to the negative 2 power minus 1. Reciprocate first, so 4 times 2 squared minus 1. 4 times 4 minus 1 is 16 minus 1, or 15. When x is negative 1, it's 4 times 1/2 to the negative 1 power minus 1, which is 4 times 2 to the first power, which is just 2, minus 1. That's 8 minus 1, or 7. When x is 0, you get 1/2, 4 times 1/2 to the 0 power minus 1. That's 4 times 1 minus 1, or 3, because 1/2 to the 0 power is just 1. So look right here, and right here. Any fraction to the 0 power is 1. And then here you get 4 times 1/2 to the first power minus 1. 4 times 1/2 is 2, and 2 minus 1 is 1. When x is 2, you get 4 times 1/2 squared minus 1. You evaluate your exponent, so it's 4 times 1/4 minus 1. And then you simplify. 4 and 4 is 1. 1 times 1 is 1, minus 1 equals a whopping 0. When x is 3, you get 4 times 1/2 to the third power minus 1. That's 4 times 1/8 minus 1. Divide by 4, and you get 1/2 minus 1, or negative 1/2. And last one, when x is 4, you get 4 times 1/2 to the fourth power minus 1. That's 4 times 1 to the 2 to the fourth, which is 16th, minus 1. You simplify, divide them both by 4, and you get 1/4. 1/4 minus 1 is negative 3/4. Okay. So I'm going to graph from here down. Okay. I can't plot this. So I'm going to graph from here down. So left 2 up 15 in red. So left 2 up 15. And then left 1 up 7. 0, 3, this is your y-intercept. One, 1, 2, 0. There's your x-intercept. So 2, 0 is your x-intercept. 0, 3 is your y-intercept. 3, negative 1/2 is right here. Write 3 down 1/2, and write 4 down almost negative 1 right here. Okay, so all of these values in the range. Okay, let's state this here. So all of these, okay, the range is always going to be greater than negative 1. This right here, that's a shift down, okay? It shifts down. Shifts down 1 unit. And that's why the range is greater than, y is greater than negative 1. All these values are greater than 1. This function will get very, very close to negative 1, but it'll never, ever reach it. And that's why there's a horizontal asymptote right here. We'll call that HA for horizontal asymptote at y equals negative 1. The range, all these range values, all of these are greater than that, so greater than negative 1. And as I told you, the domain here, which is a set of x values, they can be negative, 0, and positive. And that's why the domain is all reals for all exponentials. Okay? So, and then you got to graph this baby. So let's sketch the curve. It's not a line, it's a curve. Let me fix the bottom here. It approaches. Now, remember the asymptote, the function approaches this, okay, but never ever reaches. So the function, okay, approaches, okay, y equals negative 1, the horizontal asymptote, but never reaches it. Okay, that's just a little note. Now in decay functions, this is decay. All right, the base is This is base equals 1/2. And so this is the decay function. And you'll notice that as x increases from 0, 1 to 2 to 3 to 4, the y values decrease from 31 to 15 to 7 to 3 to 1 to 0. I mean, it's pretty darn obvious. So as x increases, goes up, okay, y decreases. Okay, it goes down. It's an inverse relationship, and something that I've been talking about in class a lot. Growth functions, they both increase. Decay or decreasing functions, one increases as the other one decreases. All right, now remember, this is a video, right? And if I go too fast, which I normally do, then rewind it, listen to it again, get better at it. Okay, listen to it 2-3 times until you finally understand it and can do it on your own. All right, now in this one here, we want to graph the exponential and the linear. So this is linear, this is exponential, on the same coordinate plane, and then find the intersection. Ooh. Okay, so here we go. Starting at -3 here. So 2 times 3 to the -3 plus 1. That's 2 times 120, 1 divided by 3 cubed, or 1/27th plus 1. So that's 2/27ths plus 1, or 1 and 2/27ths. Okay. When x is -2, you got 2 times 3 to the -2 power plus 1. That's 2 times 1/9 plus 1. That's 2/9 plus 1, or 1 and 2/9. Okay, notice what I'm doing here. I'm just multiplying the numerator. Okay, multiplying the numerators. When x is -1, you have 2 times 3 to the -1 power plus 1. That's 2 times 1/3 plus 1. Well, you get 2/3 plus 1 is just 1 and 2/3. Okay, just take 2 times 1 divided by 3, you get 2/3, and then you add it to 1. When x is 0, you get 2 times 3 to the 0 power plus 1. Okay, that's 1 right here. 2 times 1 is 2, usually. All right, plus 1, it gives you 3. That right there, my friends, is called a y-intercept. Okay, I can already see it. All right, next one. 2 times 3 to the first power plus 1. 2 times 3 is 6, plus 1 is 7. When x is 2, you get 2 times 3 squared plus 1. That's 2 times 9 plus 1. That's 18 plus 1, or 19. And since we can't go higher than that, I'm going to stop right there because I can't even graph that one. So here we go. I'm going to go left 3 up 1 and a teeny bit. All right, so left 3, 1, 2, 3, up 1 and a teeny bit is right above 1. Left 2, up 1 and a teeny bit. Left 1, up 1 2/3. Left 1, up 1 and 2/3. So we're increasing a little bit here. Right 1, up 7. Oh, excuse me, 0, 3 is right here. And then 1, 7 is right here. 2, 19 off the map. Okay. So notice this right here. This is an upshift 1. It shifts the asymptote from the axis up 1. So I know I have a horizontal asymptote here. Well, you know what? Let's do that as a dotted line. Okay, so the horizontal asymptote is y equals 1. The function approaches that, so let me draw that. Okay, keeps cruising up there. All right, and then you got to graph the linear function. Okay, the linear function is this one. Okay, so y equals -x plus 3. So the slope is -1. The y-intercept is 3 because it's y equals m times x plus b. All right, so we start at y-intercept of 3. Ooh, it's right here. Ooh, I just already found the point of intersection. All right, and you go down 1, right 1. So down 1, right 1, down 1, right 1. Okay, so let's graph this line. Okay, so this right here, this is y equals -x plus 3. This line right here, this is y equals 2 times 3 to the x power plus 1. So where they intersect, well, if you look carefully, guys, like right here, that's the intersection. Okay, and it's at 0, 3. And I'm trying to find the intersection. That's what they asked me to do. So I draw both line. I draw the line and I draw the exponential curve. And then I find where they meet, which is called the intersection point, and I write down the coordinates. And there you go. And I'm a happy guy because I solved it. All right. Okay. Lastly, let's do this. Here we go again. Let's get good at arithmetic. So we reciprocate first. So it's 2 times, come on, Ainsworth, 2 cubed. Okay, you reciprocate first. Reciprocate first. All right, and then add 4. And then you evaluate your exponents. So 2 times, well, 2 cubed is 8, and then you have to multiply that by 2 and then add 4. That's 16 plus 4, and that's 20. All right, show all the steps, guys, like I'm doing. All right, so here this is 8 times 2 to the 4th minus 4. So I reciprocate first, and then I evaluate. So we'll get 8 times what? What's 2 to the 4th? Well, 2, 4, 8, 16. And then I multiply. So let me say that's 80 and 48. That's 128. All right, minus 4, 124. Okay, same thing here. You got 9 times 3 squared plus 1. 3 squared is 9, so 9 times 9 plus 1 is 81 plus 1 more, or 82. Okay, it just takes a while. You gotta step it out, guys, just like I'm doing now. Okay, and here you have 27 times 1 divided by 3 cubed, which is 27 minus 4. Well, 27 divided by 27 is 1. So you get 1 minus 4. This is, 1 times 1 is 1, right? So you get 1 minus 4, which is negative 3. And then here you get 1 divided by 4 squared, which is 16. And then you got to subtract 1. Then you always simplify first, divide both by 2, and you get 1/8. Look at the fraction, 1/8. So 1/8 minus 1 is negative 7/8. All right, small minus big is always negative. Small minus big, all right, equals a negative number. Remember that. Okay, next one. You get 2 times 5 squared plus 3. What's that? 2 times 25 plus 3. What's that? So that's 50 plus 3 and 53, right? Next one, 4 times 1 divided by 2 to the 4th minus 5. That's 4 times 1/16 minus 5. Simplify a little bit. And you get 1/4 minus 5, negative 4, and 1 out of 4 is 3/4 remaining. So negative 4 and 3/4. This one here, you get 27 times 1 over 3 squared minus 7. That's 27 times 1/9. All right, right there, minus 7. Simplify. 9 into 27 is 3. 3 minus 7 is negative 4. And last few, so you have 8 times 1 over 4 cubed minus 3. That's 8 times 1 over 64 minus 3. Simplify. 8 and 8 is 1. 64 divided by 8 is 8. So you get 1/8 there. Minus 3 gives you a negative number, so it's negative 2 and 7/8. Okay? You reciprocate it first, and then evaluate the exponents, and then multiply first, or simplify first, and then subtract. All right, next one is 10 times 1 divided by 5 squared, 25, minus 4. Divide both by 5, you get 2 here, 5 here, you get 2/5. So 2/5 minus 4 is negative 3 and 3/5. Because if you take out 2 from 5, then 3 out of 5 remain. Okay. Next one, you get 1/16 plus 1, which is just 1 and 1/16. Okay. Now that was a lot, right? So guys got to remember here that this is a video. and because it's a video, you're allowed to rewind it and re-listen to any part of it that you want. Okay? And so use it to your advantage. This is Mr. Ainsworth, okay? Practice and use your resources well. All my videos are on my website, and you can check them out anytime, okay? I wish you the best, but you got to work hard. Nothing comes free, all right? So make yourself proud and study and practice well. I'll see you in my next lesson. This is Ainsworth. I'm out of here.